guys, welcome back. So I'm going to work this one a little bit different. I'm actually going to work the problem on the left and then work the problem on the right. So we'll go 7, 10, and then 8 and 11, and then we'll finish up the rest of them underneath. So number 7 said identify the solution for the system of equations. So this is a piece of cake. All you got to do is look at the point that is intersecting. So the location where these two lines are intersecting is located right there. Now on the test, there will be a perfect point that you'll apply. So it'll be exact. It'll be like 1,2 or something like that. But on this one, it was kind of hard because it looks like it's crossing there, and on this side, it looks like it's crossing before we get to there. So for this one, I actually said that the solution would be, well, that's 0, 1, and then that's about 3/4 of the way. So I said that's going to be 1.75, and then I say comma, and it looks like we go down. Not quite to 1, so it's between 0 and -1, so that would be -0, and then about 3/4, so that would be, once again, 7.5. So that answer is actually pretty specific answer in this sense, but that's what I want you guys to pay attention to. We're looking for where that point is located, where those two lines intersect. So on the test tomorrow, make sure you pay attention to where that point is located, and then it should be on a perfect number there, an exact number. So like it might be like -1, +2. So don't worry about it being a fraction. That was just this example. Next, number 10 says solve the system using any method. You could really use any method you want to here, but for this problem, since the x's are lined up, the y's are lined up, and the numbers are lined up, I'm going to use this elimination method. So elimination method, this one doesn't have anything matching, so I can't just eliminate anything. So what I do is I take the bottom number 3, put it on top number 2, put it on bottom, and then change the sign of one of them. I'm going to make the 2 negative. So now I just distribute it and make a new problem. So 3 times 2x is going to be 6x. 3 times -3y is going to be a negative, not a -6. That's going to be a negative, let's erase it. It's going to be a -9, right? 3 times -3 is a -9y. And then 3 times 4 is actually going to give us 12. So that's the top. The bottom, -2 times 3x is going to give us -6x, so there's our cancellation. -2 times y is going to give us -2y, and then on the end there, we're going to have -2 times 6, which is -12. So when we combine these, the 6's are going to cancel out. -9 plus -2, we are adding these, so -9 plus -2 is going to give us a -11y. And then 12 plus -2y is actually going to cancel and give us 0 here. So makes it a little bit easier for us when we divide by -11. You know, 0 divided by -11 is going to be y equals 0. So, simple solution for that. Now we got to figure out the other one. So this is a constructed response, so we do have to substitute the 0 back in. Can't just pick it from the multiple choice answers. So here we say y is equal to 0, so pick one. It doesn't matter. I like the bottom since it's all positive. So that's 3x plus y equals 6. So since y was equal to 0, I'm going to change that y to a 0. And then I'm just going to solve. Now, I did have a student today that was very, very bright. He said, well, Coach Fricks, instead of subtracting 0 from both sides, can I just say 3x plus 0 is 3x, and that's equal to 6? And I said, yes, you can. So that's what we'll do here. So if from here we can divide both sides by 3, and x is going to be equal to 2. So since x is equal to 2, remember we always write them as x comma y. So that's going to be 2 comma y 0 equals 0. Alright, so that gives us our solution for it. Alright, number 8 is a lot of reasoning. I think it's kind of just logic here. But if you look at number 8 is just, read what it tells you. Use the graph to help you with this. Like if you look, we know that this is a dotted line, right? And this is a solid line. So a solid line means that it has to be less than or equal to or greater than or equal to, right, for it to be solid. And then a dashed line has to be less than or greater than. So in that case, that means that we have a solid line and a dashed line. So that's going to tell us that we need one with a line under it, one without a line under it. And if you look, all of your answer choices are pretty much so that. There's not one that you can look at and say, oh, well, that's obviously not going to work here. So that's the first thing I always check for with these. The second thing I look for is if it's less than or equal to, I know I got to shade down. If it's greater than or equal to, I got to shade up. So in this case, both of these lines, if I put my pencil on the line, I have to go up to get to the shaded area. Same thing with the dotted line. I have to go up to get to the shaded area. So if I'm having to go up, then up indicates that it has to be either greater than or equal to. So both signs have to be that. So there's a greater than or equal to, but there's a less than, so that marks A out. This one is less than, this one is greater than, so that marks B out. Here I have greater than and greater than, so that could be a possible answer choice. And here I also have greater than and greater than, so that's a possible answer choice. So once I went through my signs and looked at what information that tells me, the next thing I do, I always do slope last if I have to, but the next thing I look at is the y-intercepts. So looking at these, I noticed that the y-intercept for the dotted line is at -1, and then I noticed the y-intercept for the solid line is going to be at +4. So the y-intercept, we know that from slope-intercept form, y equals mx plus b, that the b is going to represent the y-intercept, so that's the number on the end. So if I look at my numbers on the end, I have a -1 and I have a +4. So that's probably going to be my answer. On this one, I have a -1 and a +3. So since it has a +3, that is a 4. So therefore, that's going to give me my solution. So C is the correct answer here. So hopefully that's what you pick. And like I said, just use logic here. Reasoning through it will help you with the majority of it, okay? Looking at number 11, it says solve by graphing. Now the key here is that these are not solved for y yet, so we do have to solve for y and get them in slope-intercept form. So starting with 2x plus y equals -5, we want to subtract 2x from both sides. 2x is canceled, and that's going to be y equals -2x minus 5. So that tells me here that the slope is going to be -2/1, which means go down 2 and right 1. And remember, if we can't do that, we can always do the opposite. And then the y-intercept here, or b, is going to be -5. So to do this one, we're going to go down 5 and put a point. And then, like I said, we'll go down 2 and right 1, but we can't do that here. So instead, we do the opposite. So instead of going down, we go up, and instead of going right, we go left. So we go up and left, up and left, up and left. Until we run out of space. And we run out of space there. So after that, we can take and connect all of our dots and draw our line. Now, the second graph, y plus 2 is equal to x. That one just requires us to subtract 2 from both sides, so it's a little easier. So y equals x minus 2. And remember, x has a 1 in front of it, so that's going to be the slope is 1/1, which is going to go up 1 and right 1. And then our y-intercept is going to be -2. So here we go. Down 2. And then we're going to go up 1, right 1, up 1, right 1, up 1, right 1. And we continue that pattern until we run out of space. So we can also go down 1, left 1, down 1, left 1, down 1, left 1. That works as well. And once we get all those points, we can connect our dots. And you can see that the 2 points are going to cross right there. And that's going to be located at -1, and then -1, 2, 3. So -1, comma, -3. Alright guys, last problem. Alright, so on this last problem, it's pretty simple. I just want you to list ordered pairs of our solutions. And what you got to be able to understand is that this is going to give us the ordered pairs that are solutions in the shaded area. And that's the key here, okay? Anything in the shaded area, right? Anything over here in this area I'm drawing in. All of this will be a solution. Anything in that shaded area. Along the solid line will be solutions as well. But the solutions have to be bordering the shaded area. This is not solutions, okay? That's why I'm putting X's. Those are not solutions because they don't border the shaded area. And the same thing with the dotted line. It doesn't border that area, so it's also not solutions. But that's what's weird about this is anything on that dotted line going this route is also not solutions because we can't have solutions on the dotted line. So the only area you could pick a solution here would be anything in this dark shaded area, right? Anything in this area. And you can pick any point from that. Or anything that's on a solid line bordering a shaded area. So any two solutions you could have picked, you could have picked a lot of different things. You could have picked -2, 0. That's a solution that's located right here. You could have even picked something that's not on the line. You could have picked something back here like -8, -2. That's a solution, so -8, -2. As long as it's in the shaded area, the solid line bordering the shaded area, those are solutions. Alright, so that's all the time I have for you guys. If you have any questions or anything, feel free to email me. Hopefully this review helps you make 100 on the test tomorrow. I'll be looking to see if you've been studying, so make sure you study your hardest. Alright, good luck.